In this skill, we're going to learn to use line notation to describe electrochemical cells. In line notation, we write the oxidation reaction on the left-hand side. So that would be this part here. And we write the reduction reaction on the right-hand side. This double line in the middle represents the salt bridge that connects the two. And these single lines represent phase boundaries between the different species taking part in our reaction. We always write the electrodes on the outside. So this is always going to be an electrode, and this is always going to be an electrode. Since the left-hand side is the oxidation reaction, this is going to be the anode specifically. And since the right part is the reduction reaction, this is going to be the cathode specifically. And then on each side, we're going to write our reaction with the reactants first, and then the products. So those are our general rules for writing in line notation. In this specific question, we're carrying out a reaction involving copper and iron in the electrochemical cell shown in the image provided. So we can see we have a copper electrode in copper 2 sulfate solution and an iron electrode in iron 2 sulfate solution. We also have a potassium chloride salt bridge. Here's our equation describing our reaction. So our first step is figuring out which is oxidized and which is reduced. So starting with copper, we have copper 2 plus on the left, aqueous, and copper solid on the right. So we've got copper 2 plus, aqueous on the left. Then we've got copper solid on the right. Right now we have a charge of 2 plus on the left and a charge of 0 on the right. So to balance that out, if we add 2 electrons on the left here, the charge on the left is now 0 and the charge on the right is 0. So copper 2 plus is gaining electrons to form copper solid. So this is a gain of electrons. Remember, we have oil rig, which helps us remember that oxidation is loss of electrons and reduction is gain of electrons. So in this case, for copper, we're gaining electrons. Gain of electrons is reduction. So copper is reduced. Next, let's look at iron. On the left, we have Fe solid. On the right, we have Fe2 plus aqueous. So we've got Fe solid. We end up with Fe2 plus aqueous. Right now, our charge on the left is 0. Our charge on the right is 2 plus. So if we add 2 electrons on the right, the charges will cancel out there to give 0 as well. So that balances. So we can see that iron is losing electrons to form iron 2 plus. And loss of electrons is oxidation. So iron is being oxidized. Awesome. Okay. So we know that the anode is where oxidation takes place. So that means iron must be the anode. So I'm going to label that on here. This is the anode. And the cathode is where reduction takes place. So that means that the copper electrode must be the cathode. So the anode is always going to be the very leftmost thing, which was iron solid. And the cathode is always going to be the very rightmost thing, which was copper solid. So we know that iron is the left-hand part of our line notation. So this is it's called a half cell, the part that has iron in it. And then the right-hand part of our line notation, this half cell, is the one with copper in it. And then within the half cell, we should show reactants and then products. So for iron, our reactants were just iron, and our product was iron 2+. So that's going to be here. And then in this half cell, we start with our reactants on the left, which is copper 2+, and we end up with our product, which is copper solid on the right. So that's how we write line notation to help show the information for an electrochemical cell in a much simpler way. Let's do one more question. So again, we're going to have the oxidation reaction on the left. And we're going to have the reduction reaction on the right. And we're going to start with our electrode. This one will be the anode because it's the electrode where oxidation is happening. And we're going to end with our other electrode, which will be the cathode because that's where reduction is happening. And then within each of our half cells that we show, we're going to have reactants first and then products. Remember, we also have oil rig, which tells us that oxidation is loss of electrons and reduction is gain of electrons. In this question, we're carrying out a reaction involving manganese and chlorine, and we're using one manganese electrode and one inert platinum electrode in an electrochemical cell at 25 degrees C under standard conditions. So we can see here we've got one manganese electrode here. We've got one platinum electrode here. We have a solution of manganese to chloride. And then we can see that chlorine gas, Cl2, is being produced at that electrode. Again, let's start by figuring out what's being oxidized and what's being reduced. So for manganese, we start with Mn2+, we end up with Mn. So we've got Mn2+ ions in solution. We end up with Mn solid. To balance the charges, we've got to add 2 electrons on the left. So this is going to be a gain of electrons. And we know from oil rig, a gain of electrons means reduction. So manganese is being reduced. What about for chlorine? We're starting with 2Cl- on the left and ending up with Cl2 on the right. So we've got 2Cl- aqueous on the left. We're ending up with Cl2 gas on the right. So right now our charge on the left is 2-. So we're going to need to add 2 electrons on the right hand side so that our charge is 2- on both sides of our equation. So here, chlorine ions are losing electrons to become chlorine gas. So here we're losing electrons. And remember, a loss of electrons means oxidation. So that means chlorine is being oxidized. Okay, so chlorine is being oxidized. So the chlorine electrode is going to be our anode. Here's the electrode for chlorine. It's made of platinum. So this is our anode. That's where the oxidation is happening. And then the manganese electrode, that is our cathode. That's where reduction is happening. So over here, we've got our anode here. Our anode is made of solid platinum. And then for our cathode, that's going to be made of solid manganese. Then we have our reactants and then our products in each half cell. So in the chlorine half cell where oxidation is happening, we've got our anode first, then we're going to have our reactants and then our products. We can see from our equation our reactants is the chlorine minus ions in solution, and our products are the Cl2 gas. Then on our reduction half cell for manganese, we're starting out with Mn2 plus ions as our reactant, and we're ending up with Mn solid as our product, which is also the electrode. So our steps in these questions are first figuring out what's oxidized and what's reduced. The easiest way to do that is by writing a half equation for each of those reactions. If it gains electrons, that means we've got reduction. If it loses electrons, that means we've got oxidation, according to oil rig. Then in line notation, the left-hand side is going to be the oxidation half cell, starting with the anode, then with any reactants and products. And then the right-hand side is going to be our reduction half cell, starting with the reactants and then the products, finishing up with the cathode. Sometimes our anode and our cathode actually take part in the reaction, and they are the reactants or the products. Sometimes, like in this question, the electrode doesn't take part in the reaction. Here we have an inert platinum electrode which doesn't actually take part. So that goes first, and then we have the reactants and then the products.